Okay, welcome back. Really hope that you guys have a very good lunch, and I really hope that you guys can just took the opportunity to either rewind the video for this morning if you have missed it, or if you would like to just revisit it. Yeah, it's a very good call to make use of that 1 hour period to just go revisit everything that you wish to. So coming back from the lunch, let me just go back to the agenda. We are here again for the continuation of the utility sharing session, part 2. So again, it's going to be chaired by the same person, Mr. Nick. And hence, I would like to just pass this session to him for him to introduce the next presenters. Well, the stage is yours, Mr. Nick. Over to you. Mr. Nick, I think you're muted. So sorry.
Okay, can you hear me now? Sorry. Yeah,
yes,
this is
yeah,
sorry. It's first time handling the online session. Okay, I think you can see my screen now. I think it's the same one that Hasro left off. So today we're gonna have 2 more paper coming from our counterparts. I would say that our counterparts in Europe. We are listening. We have listened to people, our other friend from the States, California and Arizona this morning, and then followed by 2 Malaysian company, Tenaga Nasional and Petronas. And now I think for this afternoon, we will be listening to 2 more very interesting paper from paper number 1 will be from Aliander, Netherlands, and paper number 2 will be from RTE, France. Okay, let me introduce the speaker. Our speaker will be Mr. Sander Jensen. He's a product owner for the virtual substation, really the man that we want to actually listen to, because a product owner of the topic that we are discussing today. Mr. Jensen has more than 10 years experience in the SO sector, in the sector of age of business, IoT, IT and OT. And then he has a vast knowledge in IC 650 and also IEC SIM, Common Information Model. Okay, now he's with Dutch DSO, namely Aliander, serving I think Amsterdam area. So that Mr. Sander will actually introduce his company after this in a brief summary. Okay, the paper he's presenting today is about the more onto the configuration tools, and then sorry, Mr. Sander also work in the collaborative group under Linux Foundation, and then is working specifically on the 650 SCL tools. So without further ado, I would like to invite Mr. Sander to deliver his presentation. Thank you.
Yeah, thank you for having me. I will load my presentation. Can you guys see it?
Yep.
Okay. Yeah. So thank you, Nick, for the introduction. So my name is Sander Jansen, and thank you for having me on this forum, this discussion. So a little bit about me and the company I work for. So I work for Aliander, and our DSO is called Leander, and we're serving large parts in the Netherlands of with electricity and gas distribution. So we serve in multiple provinces. And yeah, that's the only business we do. So we don't do any production or trading besides buying electricity for our grid loss. So that's what we do. yeah, I have a background in data architecture. I worked on specifying SIM interfaces to integrations with several applications, and I studied electrical engineering. I have a bachelor degree in that. Yeah, from the utility perspective, we're facing a lot of challenges. We're in the news everywhere in the Dutch media, and one of the reasons is that we see a changing mix of energy. So we go from fossil to renewable, and that leads, for example, to more electricity production location. So what happens is that more customers want solar panels on their houses, but also they want solar farms. So they buy a piece of land, and then they put solar panels on top of that. But those pieces of land are generally in the less populated areas where the ground is a little bit more affordable. But those locations don't have a strong grid due to historic reasons. So therefore, we have a hard time connecting people to the grid, and we see more and more congestion showing up on our grid. And besides the increasing renewable energy production on decentralized locations, we also see a higher use of electricity, for example, by using electric cars. There are more and more electric cars on the road in the Netherlands. And another challenge we have is finding technical staff. So we have a huge amount to do as a company to serve all the customers or the customers that want to have an upgrade of their grid connection. So that's a challenge as well. So we have grid congestion, and our grids are not built for that. So, for example, in the more farmer areas, the grid was laid out for just farming, and that worked well, but was not laid out for massive solar plants. I also added a map here of the Netherlands, and these are the areas in yellow, orange, and red. Where there's some kind of congestion, and where it's hard for customers to get a new grid connection. So as you can see, there are large parts of the Netherlands where people need to wait if they want to have a pretty big grid connection, because we need to do a lot of upgrades. So besides upgrading the grid, we this year started a new department, system operations, and I'm part of that department. And the goal of system operations is to try to see if we can control the electricity flows a little bit better, and at least max out the available grid capacity. And so we have multiple ways to do so. We have a system called GoPax, where we can go to the market and say, oh, can you change this production location to this production location? Colleagues working on a direct control for connecting parties, so that we can say, oh, we have a congestion, so please reduce your load. So we can leave the N-1 in certain cases. And I'm more involved in the substation automation. Because if you look at substations, they're critical part of the electricity system. And I think the higher use of substations, if you're operating your grid on the edge of the capabilities, I think it's critically important to know exactly what's in the substation, what functions are running, and some possible things we could do in the future is dynamic protection settings. So we have power cables in the ground, and they heat up and cool depending on the load and the outside temperature. And what we can do if we get that mathematical model right is say, okay, this is now the ground temperature, this was the consumption last 24 hours, so this is the cable temperature. And based on that, we can say, okay, for this hour, maybe we can allow a little bit more distribution over that cable. And that leads to that you probably need to change the protection settings, so the protections does not interfere with your ID. Maybe we need some more adaptive automation function. For example, we have to switch off certain parts of the grid when the frequency is too high or too low, and that certain parts can change over time as well. So yeah, if that's the case, you probably want to look for the areas that has the least impact on your consumers. So therefore, that's a function that can change as well. And overall, yeah, it's very important to know what's in the substation. So yeah, great data management is very important. So know what configurations are running, what's the actual state of the substation, and how to deploy it. Because if you change settings more oftenly or change the behavior of substation depending on the location and the grid state, it's very important to know that that process works well and also pretty fast. Yeah, where are we today with the current substation? Yeah, today what you can buy in the market are pretty much black boxes, proprietary IDs, which have the hardware, the software, and the orchestration management. And if you make the analogy with the telecom sector, you saw something similar in the past. The telecom sector was also a bunch of black boxes in the past, but they did some diving innovation and market disruption by using virtual functions, automation, software defined, and disaggregation. And I think the same thing will happen to the substation. At least that's where we are working on. So you probably get a layer for your hardware, a network layer, operating system, orchestration, and on top of that your services apps. And what I see as the main advantage here is the flexibility. So in case of the dynamics of the substation changed, and you want to say around the substation change, and you want to change the functions, if you have a flexible open stack, it's probably more easy to do than drive to the substation, change some settings, or replace devices or add devices. So I think that's where the benefits comes from in terms of virtual substation. We decided to take the open source route. Open source leads the way. If you look at the IT industry, yeah, most software or at least infrastructure parts are open source. So, for example, Linux. And yeah, why is open source so popular? Yeah, everybody can see the code, make changes, and commit back the changes, and they also can use it. And that essentially means that every party can drive their own roadmap. So you don't depend on a specific vendor for the parts that are open source. You can say I want to take it to a different direction. So it gives you a lot of freedom, flexibility, and less dependency on the vendor. It's composable. Yeah, you can reuse it, and with the LF Energy, we try to make the software agile and obviously also pretty robust. So LF Energy itself is an energy consortium which consists of multiple utilities and vendors that actively working on open source projects. There are many projects out there, but I'm mostly involved in the Compass project. But I'm also highly interested in the CPass project, which will come up next. So in terms of architecture, from the LF Energy perspective, This is how we think the future of the substation could work. So on the left side, you got your merging unit or your digital instruments deformer. There are some standards for that, how the interface is defined and what the characteristics should be of those devices. Then you got your process bus, and you can run your protection functions or whatever functions you want to run on a platform, for example, CPaaS. So the idea of CPaaS is have a infrastructure where you can run those applications, and then you go with your station bus to a gateway. In LF Energy case, it's a Fletch Power, and then you go to a central system. And my idea from gateway to central system is also to use 61850 there. Because if you convert to 104, then you're losing information. You make conversions, which also add load to your workforce and complexity. And all of this is managed throughout 61850 substation configuration language by the LF Energy project Compass. So what's the goal of Compass? Yeah, the goal of Compass is to open source software for 6150 model implementation and configuration, and it's specifically built for the power industry protection, automation, and control system. So the main focus currently is on substation and grid automation, but 6150 can also can be used outside that, and I think it should be possible to use it for our other use cases as well. For example, the DER control or wind farms, controlling wind farms. So what use cases do we have in mind with Compass? We want to allow requirement specifications for the substation in the tool by using 6150 as well. Grid planning. I will come back to that later, but we want to convert from SIM to 61850. We want to support in operational changes. So you say, I want to change something in the substation, and so what changes need to be made? We want to facilitate that. Asset management and asset management planning. So what's in your substation? What's the status? What can we replace? And we want Compass to be a register for the substation configurations. So other applications or interested party within the company can see, hey, what's going on in that substation in terms of configuration. And if you have a register of substation configuration, you can also interface with other systems like SCADA, configuration management database, grid control systems, etc. So the idea is also to support top-down engineering. Yeah, for the tech guys out there, we're using a microservices architecture. So small services with dedicated tasks. We're using OpenSSD as the front end. I will show later JavaScript, and for the back end we rely on Java and Basics as a XML database. And our microservices can run in Quarkus, which is a Java framework to run your application. So we already did some development in terms of Compass, and I think we already have some nice features. So we have a SCL data store service. So we have a database where you can load SCL files, and we added versioning on top of that, because I think it's very important to know what changes are made to SCL files over time. So that's included. We built an early version of SIM to 6150 conversion. We added a security layer because I think it's important to keep track of what's going on with your configurations. So if you go to the server now, you get redirected to an identity server, and then you get your rights. So we also get role-based access per file type. So we're currently supporting all the SCL types, and on per type you can set the read, create, update, and delete rights. What Compass also supports is displaying and editing SCL files, and Compass has also multi-language support. So if you're interested, you can convert it into your own language. Active contributors to the Compass project are RTE. They currently contribute by with their knowledge about the 61850 processes, configuration processes, but also adding code. We from Oleander are active contributor, and we closely work together with OpenSCD, which is an open source project run by Omicron, the guys from the testing equipment. And they also, behind the scenes, they are backed by Transnet BW. That's a German TSO. So the German TSO asked Omicron to develop the OpenSCD. And we're actively working together. And that's really speeding up the development and also the knowledge in the solution, and make it more flexible. So we're open source. So if you're interested, you can always join the development or check it out. So in terms of 61850 workflow, so what we're currently working on, my colleagues are working internally on a connectivity register that gives SIM files, and then to be more specific, CGMES EQ. CGMES stands for Common Grid Model Exchange Specification, and EQ stands for Equipment. So that's the SIM profile that specifies where do you have a breaker, where do you have a cable, what transformer do you have, all the basic electrical things. And the idea is to that if you want to engineer a substation, you go to the connectivity register with the as-built grid or the as-planned grid. Then you select a substation, and then you convert the primary equipment to 61850. And then using the Compass substation configuration tool, you can add your templates or add your logical nodes. And then you can currently via third-party tools, you can upload the settings to your ID. And the ID could talk to the SCADA system, for example. And if you take the identification of SIM within your 61850 files, the SCADA system could use that to see, okay, this measurement point was here in the substation, or this function is running in that substation. Because currently we have some challenges in figuring out the data points and plotting them to the grid. By using this way, we can manage that in the long run. But what I want to show you is just that red box where we want to convert a SIM file into a 61850 SCL file. So now it's time for a demo. Like I said, we're interested in collaborating. So if you have some insights, or you want to try it out and you have some ideas or your other user feedback, feel free to join. Maybe we can help with implementing that. Let me share my screen. So now I open up an open source program to see SIM files. Let me check. And I will upload an example grid here. And then I can select the diagram. This is a CGMES NSOE example, but I just wanted to have a substation for testing purposes. So you can see here all the components modeled in SIM. You can see here the substations with their voltage levels and their base. So what we are basically doing is I want to select this substation, and I want to convert that into 16150. The current conversion script converts everything, so also the other substations. But this is the thing I want to show you. So now I go to OpenSCD. So this is currently running on our internal system. However, we have a Docker Compose for the tech people out there, which allows you to install it on your local machine and get it started. There's currently a bug, so I will reload. Make the chance a little bit smaller that occurs. Sometimes I see a white screen, so developers are looking into that. What's the issue here? So I will open up a SIM project. So I will select the example grid. And now the software is transforming SIM to 61 and 50. So now we have to wait a little bit. And here it is. As you can see, the 380 kV has 3 bays, 30 kV has 2 bays, the 110 kV has 4 bays, and that matches well with the drawing here. And with this front end, yeah, you can make modifications. You can add logical nodes to it. You can select IDs in this project. It's a new project, so it's hard to see. I can open another example here. And we just we don't use it in production yet. It's just for testing and see how far we can get. But we try to make it stable software. So this is another example project. You see the IDs here, and you can also make some communication settings. You can see the templates, logical nodes, object type, data attribute type, enums. You can manage that here. And well, I can add a new version to this. So let's say I save the compose, and I can choose if it's a major, minor, or patch. I will say it's a minor, and then I can add some comment. And now a new version gets saved to the database. And now you can see I went from 100 to 110. Yeah, so that's basically the demo for now. I will switch to the presentation mode again. Yeah, so what do we have in mind for future development? We can improve the SIM to 61 and 850 conversion. We already added the power transformer to it. It doesn't show in OpenSCD yet, but the guys are working on that. Our idea is also to display a single line diagram to see, what's the diagram of the substation setup. Want to have an option to compare versions, so to quickly find out what has changed in the SCD files. We want to show the T history, so the history of the SCD files. STL files, and we want to add more edit and display capabilities. Yeah, like I said, you are more than happy to join the Compass development. You can ask questions about Compass. With LF Energy, we have a Slack channel. You can subscribe to that. You don't need to be a member of LF Energy, by just hang around and ask questions or contribute to a project. You can find us on GitHub. We have an LF Energy a Compass mailing list. To be honest, we're not that active on the mailing list, so I highly recommend to join the Slack. And if you're interested, we also host community calls. I think once in 2 weeks, and you can find them on the calendar. Yeah, to ask your question as well and to see what's the progress of the project. So that's basically my presentation. Back to you, Nick.
Thank you, Sanders. A very detailed walk through through the tools. I'm glad. Can you hear me? My voice? Okay.
I can hear you.
Okay. Now we probably waiting for Q&A. There's a Q&A session. Yeah, there's some coming in. Okay. Okay. I just throw you one question first. Does Compass, the tools, substitute the need for user to design the SCD file using third-party tools like SEL metrics or healings? Or do you know about that tool, right? The tools that for people to build the SCL file. Yeah.
So the question is if Compass can replace healings or one of the other tools?
Yeah.
Yeah, I think in the current state maybe not. But in the future, it might certainly an option to use just Compass instead of the other tools. Okay. But that then depends on the development and the way you want to use it. One of the things we want to work on is also generating substation configurations, and as far as I know, that's currently not in one of the other tools. Because the main advantage of Compass is that it's made for automation, so you can ask API calls to make changes or to store and load things. And what I saw from the other tools is that are pretty more desktop-oriented tools, so it's harder to automate or to integrate with other systems. But to be honest, I did not check SCL matrix, so that's a new one to me.
Yeah. But anyway, okay, let's have question number 2. Also, how do you incorporate the requirement and files defined in 650 part 6-2 for HMI?
Yeah, for the HMI part, we don't have a particular plan yet. I think it would be very nice if we can design the HMI according to the specification as well. But that's currently not foreseen. I'm happy to see contributions and maybe maybe the roadmap changed or we're moving quick with other developments, and then we can look into that.
Okay. Okay. This is one of additional question that I put into why open source.
Because why open source?
Yeah.
Yeah, I think my personal opinion is openness always wins in the end.
Okay.
Yeah, I think companies and also people want to have freedom. They want to know what's going on in the software. And yeah, we have to experience that it's sometimes hard to work with vendor to get your requirements in, or they have their own roadmap, or they want to sell you different modules, etc. So, and by using open source, you're taking back control. In terms of support, you can say, oh, open source, I have to do it all by myself, and that's also costly, and I can nobody call if there's an urgent need. So what you're seeing in the open source world is also that there more and more companies show up that provide you with commercial support. So you have the benefits of open source. You can look into the code yourself, or maybe build some new features. And if you're concerned about support, then you have a support contract with a third-party company that's also actively involved in the community that can help you out with that one. But in general, it's the flexibility and allowance for speedy development and taking back control over your own roadmap.
Okay. So open win at the end. So that is the philosophy. Okay, I'll take that. As
That's
an answer.
that's what I
The philosophy.
took from an OSCON conference a couple of years
that,
ago.
that's a good one. Yeah.
But if you look
Okay.
at the IT sector, I think open source has won there as well. It's used everywhere. So why can't we use it in our domain?
Yeah. I agree. Okay, the next question. Oh, sorry, Sander. I still have that. Yeah, sorry.
Yeah,
Go
I can
on
elaborate
Microsoft.
more, but because I think we as an industry we're pretty risk averse due to the nature and the demands from our customer that everything has to work reliably. I think so. Therefore, open source could be a little bit scary, but I think in the end we can get there and make it work, and we already do it in Alliander with multiple open source projects.
So I think that's good. Also, you are using this opportunity to share the links and to share the collaboration that other people might want to contribute to the community. Yeah. Okay.
Yeah, what I also see as a major benefit, especially if you look at LF Energy, we also share a lot of knowledge about our issues, because if you work together on open source, you have to tell, hey, what's my problem, what's your problem, and therefore you make the solutions also more generic. And also architecture discussions. There are a lot of working groups in LF Energy, so even if you're not interested in Compass, then it could be still worth to join the other conversation.
So one question about that is probably that we do not contribute to coding, to the technical stuff internally, or probably some of the people also can contribute to requirement because they have a specific requirement. So there's those kind of.
Yeah. So contributions can vary from I just want to help out with organizing stuff or ask questions to I have ideas for the software, to or I will help to improve the documentation, to I will help with the architecture or with the actual coding or testing, or so there are multiple ways to contribute.
Oh, that's good to hear. Yeah. Okay. All right. So the next question would be, could these tools include the substation algorithm or logics to build a function, not just the configuration of that, logics, meaning that probably the question will revolve around IC 61. I mean the functional logic 61131, something like that. Yeah.
So for the actual, you mean protection logic, for example?
Yes. The scheme. Yeah.
Yeah. So currently we with Compass, the idea is to have all the settings for your protection and also the setup. Yeah, everything you can configure in 6150 SCL. If you talk about the actual protection algorithms, etc., I think that has more place in the CPAS project. And yeah, what do you find very important? That's an open ecosystem, so that it also integrates with third-party devices, also currently proprietary or third-party algorithms. But if you look at the market today, most of the devices can be configured using 61 and 50 some way.
Oh, that will be okay. The other question would be the okay, because this is open source, I know, but probably this is a question that I should ask also. Do we include the equipment not in standard, like not in SIM standard, like temperature sensors?
It's because we do template engineering currently. We don't do top-down engineering because template engineering is easy if you have a contract for multiple years from one vendor. And with the template engineering, you can say, "Oh, I just built a new substation and I want a temperature sensor in it." That's the current ID.
Okay.
And as long as it's 61 and 50, you can you can add it in Compass.
Okay. The other thing would be question along the integrity of the code inside the open source. People can go in and change and do work. I don't know. That is how do you handle that in this environment?
Yeah, so yeah, we're highly focused on security, obviously, for the same reason that where everybody in the industry is a little bit risk averse. So in terms of security, we have the LF Energy security scanner. So we check code on known vulnerabilities. We have static code analysis. So we check if the code looks fine from an automated perspective. We do reviews of code. So if somebody sends in a change, one of our developers will look at it, or somebody else from the open source community will look at it. And what we also do is we recently installed the PandaBot, and so we get automatic notification from GitHub if there's a new version of the package. And new versions usually contains patches, and sometimes it's also a security patch. So if you stay on the latest, it's fine. And yeah, and if it's really necessary, I think we have to work upstream as well to fix security vulnerabilities if that's needed.
Okay. Okay, it's gaining a lot of interest. The question is coming. So will Compass evolve into the API gateway for CPaaS microservices?
Yeah, so my idea is that we stop at the SCL layer. So we just provide, oh, this is the configuration of the substation, and then CPaaS can take that, and or the CPaaS infrastructure can take that and say, okay, this is the functions we want. Okay, we have a library of all the functions, and we can make a configuration or generate a configuration that you can deploy on an actual substation or test it virtually.
Okay, one last one from me. If people are interested, people around the world now interested in this, what is the best mode of getting started, or like 101 type of thing?
Yeah, I think the best way is just trying out the software and testing it.
Get into the GitHub.
Yeah, go to GitHub, and let me check quickly. I think you can go to the configuration Compass deployment, and that repository you can find instructions how you can install it or try it in your own environment.
Okay, I think we are okay. I'll let organizing committee get that the link for everybody, and then post it on the chat or something that it can pick up. So I think that's probably good to for the way at least a starting point for the people who are interested in it. So that's a very good way to do it. Oh yeah, it's already in the chat.
I put it in the
Okay, that
chat.
chatbot is for organizing committee, but anyway, we can actually copy that into the general public. Okay, very nice and very comprehensive, and then good question and answer session, I think. And then I think this sparked a lot of interest among the utility to see that this going open source, and of course you're also saying that we have to also take care of the risk averse environment that we have in the power utility, which is being considered. And then also your opening up I would say that the opening up of the contribution to open source, that we probably can go on any area that we want, ask question, even put up a requirement, all those kind of thing. Yeah, I think that will be good. It will be gathering the more people into the community. Okay.
Yeah,
great.
the more the better. The bigger they grow, the more functionality, the more market adoption, and then
yeah. I'll say that. Okay. I think we I got that signal that we have all the time. We're gonna and then we probably have we'll contact I mean, not in the conference. I mean, we can be in contact with you, and to know more, and then also to try out the one on the LF Energy site. Yeah. Okay. Thank you. Thank you very much, Sander.
I will share my slides for the audience.
Sure. Thank you. Thank you very much.
Thank you for having me.
All right.
Nick, mute, Nick.
Yeah, I think I'm on now, right?
Yes,
Okay.
clear.
Okay. Our next session will be a pre-recorded session. However, the speaker will be with us in the question and answer session right after this. It's also one of the I would say that the initiative is under the LF Energy, which is called CPAS. Yeah, the previous presentation by Mr. Janssen is on Compass, but this is another group that was working on CPAS. It's a virtualization for real-time power grid substation automation. This is like we are looking into virtualizing the protection, automation, and control. Let me introduce the speaker first. Mr. Watare Aurelion. I hope I pronounced it correctly. Mr. Watare Aurelion is with RTE of France. He's a project manager with RTE is a French power transmission system operator. He's in charge of the virtualization of the digital substation. The paper on the CPAS virtualization of real-time power grid substation automation will cover the objective with the objective to develop the reference design and the industrial grade open source real-time platform that can run virtualized automation and protection application. This is a very interesting subject. So let's go to the video recording. There's two parts. Sorry, the video recording will be two parts. One is the general recording, and the other one is the presentation by Aurelion. So can we play the video now?
Comme toutes les grandes entreprises, RTE doit être au rendez-vous de la digitalisation. Oui, même moi. L'un des projets phares de virtualisation des systèmes se nomme CIPAS, un projet open source de développement d'une plateforme temps réel haute disponibilité. Rien à voir avec la mer, même si CIPAS amorce bien une nouvelle vague. Aujourd'hui, le contrôle-commande est composé de nombreux équipements. Avec CIPAS, on met tout ça en boîte. CIPAS pourra entre autres orchestrer et exécuter des applications virtualisées de contrôle-commande des postes électriques. Ce socle de virtualisation permettra par ailleurs d'y accueillir l'intégralité du fonds de poste numérique. Aujourd'hui, RTE possède des systèmes fermés, dits boîtes noires. La virtualisation permet de passer du tout matériel à du tout logiciel. CIPAS est certes disruptif, mais plein de promesses. Développer la virtualisation, c'est par exemple diminuer les coûts de maintenance. Mais le but n'est pas de multiplier les plateformes virtuelles, plutôt d'avoir une référence commune, ouverte et partagée au sein de l'industrie. À plus long terme, il sera notamment possible d'atteindre un complet contrôle-commande virtualisé et de tirer profit des possibilités offertes par cette plateforme pour d'autres innovations. La mise en œuvre de ce projet open source offre à l'ensemble des fournisseurs la possibilité d'utiliser cette plateforme pour développer et fournir des solutions de contrôle-commande dans le futur. La virtualisation a déjà transformé le secteur des télécoms. Elle sera incontournable pour les réseaux électriques de demain. Alors bon vent à CIPAS!
Welcome, everybody. Thank you for being here. So you just saw a brief video of how RTE is going to use the CPath project. Now we talk about virtualization for real-time power grid substation automation and the CPath project. And I'll be the speaker today. So I'm Aurélien Ouattara. I work at RTE, the French TSO, as a substation automation engineer. And I'm also a member of the technical steering committee of the CPath project. So we'll talk about it more in details afterward, but I just wanted to let you know that CPath is the result of a collaboration between two major European electricity players, RTE and Alliander, and open source expertise, Savoir-Faire Linux. Okay, let's move to the next slide. So what is the context? The energy transition is underway. There are more and more renewable energy sources, electric vehicles, and smart services. So the grid needs to adapt. It needs more flexibility. There are also more and more data to manage, so we need to be able to manage it. And of course, this evolution should be cost effective and able to manage with all the materials that are already in place and the obsolescence. So how is it today? From where we start? Today, in a substation, we have multiple equipments that are distributed in bays. So in bays, you will find SCADA function, automatons, protections, sensor, and of course, digital I/O to get current, voltage, and binary input and output from the high voltage equipment. So we have each equipment that contains several functions. You can have one protection equipment that contains, for example, an overcurrent and a distance protection, automatons that have several roles, and same thing for the SCADA. So you will have a bay for one or two feeder, and then at the substation level, you will have features like monitoring, administration, non-critical automatons, SCADA, and the link to the data center and control room to manage everything. So we have lots of equipments, and the functionalities and the hardware are bounded. It's impossible to speak about functionality without speaking about the equipment. The virtualization is an opportunity to have a new grid control architecture that is more flexible, more adaptable, and that can manage obsolescence and be cost effective. So what is the idea? Instead of having multiple equipments, we can have one single type of platform that can host all the functions. So let me show you. So on the previous slide, we were at the power grid substation level. And remember, we have lots of equipment in bays and at a substation level. In this vision, we only have one platform that is in green here. and that platform can host all the functionalities. So you do not have to think about the hardware anymore. We just speak about functionalities, and the platform is able to handle protection, control, monitoring, SCADA. For more reliability, you can have 2 platforms or 3 or 4 in order to have a high availability and to be able to be resilient if you lose one hardware. What is nice about this approach is since it's just a standardized platform, if you want to use it to have a digital twin in your data center or the place where you qualify your equipment, it will be pretty easy to have a replica of what is in the field, since you do not have to buy lots of equipment. You just need to buy the platform, and you will be able to replicate exactly what you have in the field. So that is the idea. The idea is to have an implementation of a reference platform that can host all the functionalities. And there is another project at the Linux Foundation Energy, Compass, that aims to be able to set up and configure all the functionality that will be hosted on this platform. Okay, so the platform we are talking about, in our case, we think could be good if it was CPAth, so Software-Enabled Automation Platform, Artifact the Rain. That's the platform we are developing with the LF Energy. What is the goal of CPAth? The goal is to develop, as I said before, a reference design and industrial grade open source real-time platform that can host virtualized automation and protection application that can be shared between multi-provider. So it should be hardware agnostic. In this platform, you should be able to install application from any vendors. And of course, since the grid is a critical asset, we should combine performance and safety in terms of cybersecurity. Okay, so now we know what we want, but let's see more in depth what we are talking about. As I said before, we want to host all the functionalities that are in the substation today. And the most critical one are protections. And for protection, you need real-time. So this platform needs to be able to handle real-time functionalities. Of course, since now we are moving to IEC 61850, everything, all the communication are virtual. So we need a low latency network to be able to communicate between the functionalities. To ensure that there is no conflict and that we do not require the biggest machine to make it work, and also for cybersecurity issue, we need to have a minimal services configuration. It means that in the platform, you should have just what you need and no more to ensure that it's working perfectly. Of course, it is linked to cybersecurity. We need to ensure that it's perfectly safe. Since a lot of functionalities now in the substation are network related, so we have lots of switches, for example. If we want to virtualize everything, we need to have software-defined network. It means that instead of having real switches, we need to be able, all the configuration directly in the platform and to have virtual network. Like I said before, we are in a critical sector. The grid is critical. So for some substation, it's impossible to lose them. That's why we need to have high availability feature to be able to be resilient if we lose one or two equipment. And of course, we want to host applications that were before in a real equipment. So we need to be able to handle a virtual machine and containers. Okay, but is there any existing solution on the market? Because of course, we are in the grid sector. If there is something out there that is working fine and can fulfill the need, why do we bother to build another one? So what we found is you have either some solutions that are providing high availability and virtualization, some other real-time platform, some other are low latency platform, but you do not have a mix of that with minimal firmware and that are highly configurable. So that's why we started the CPAP project to create our own Linux distribution that will be the base of the platform. However, we do not want to reinvent the wheel. We do not want to code and have to maintain such a platform. So how could we build a new distribution that fulfill our need without coding anything? That's where we found the Yocto project. So what is the Yocto project? The Yocto project is, I would say, for me, it's like a logo factory. So it allows you to create a custom Linux distribution from tons of open source components, including virtualization and high availability. So instead of recoding everything, we do like we will do with Lego. Thanks to your Yocto project, we take the component that we want and we focus on putting them together and configure and modify each component. So there is no code. It's more about the configuration. So what I see is the CPAP project is more a configuration project based on the Yocto project. And thanks to that, you do not reinvent the wheel and you can create a custom Linux distribution that is agnostic from tons of open source components. And you know that you have the support to check all the common vulnerabilities and exposure. And if there is an issue, each component will be patched from the provider. So it is a widely used project in the industry. So with strong sponsor like Intel, WinRiver, Cisco. So it's a strong base for the project. Okay, so what have we done with Yocto? So we said that we can assemble lots of components, but what do we need? Let's start with the bottom. So as we said before, for the platform, we have automatons, protection, SCADA functions. Some are real-time critical, some are not. So the first thing to be able to do is to split, I would say, the hardware into best efforts and real-time. So you will have dedicated CPUs for best efforts like SCADA functions, and dedicated CPUs for real-time like protection. We'll do the same for the memory and the same for the network. So you have a part of the network that is critical, that can be 61850 network, and you have a part that is more for administration. Okay, so this is the hardware part. On top of that, you will have the Linux distribution that we've built with the Yocto project. So which component do we assemble? So I'm not going to go in detail here. I'm just going to take the biggest one. So you have pacemaker and safe. Those components are used for high availability to be able to replicate the data from one computer to another in order to be resilient. You have KVM for virtualization, Open vSwitch OVS for everything relating to the network, virtualization of the network, and DPDK. This is a driver from Intel that allows you to manage directly your network card in order to have better performance. And the platform, on top of that, you will have services, platform services. So redundancy, network administration, fault detection and recovery, of course, cybersecurity, features to monitor the platform, and so on. So those are the services that will be provided by the platform. And with all those things, you will be able to host your third-party services, so protection, gateway, IT61850 tool, automation app, OT, and so on. And those applications can be yours, or you can buy it from directly from vendors. With this platform, you will also be able to use cloud services. How can you use CPAF? Okay, so as I said before, the idea is to be able to provide people with something that can provide high availability. However, depending on the size of your substation or the way you want to build your project, you may not need high availability. You may just need a simple virtualized platform to host your virtual machine. So that's what is nice about Yocto. So you can build different versions. And you can, for example, that's what we see on the left side, and you can build one version that is not that does not contain the high availability components. So you can build a simple machine with the hardware, the Linux RT, and just, for example, Open vSwitch for the network, KVM for high availability, and then you will be able to host your virtual machine, and you do not take the high availability part. Or what we saw on the right side, you have an architecture with 3 computers. So we call it a cluster, and it's more complicated, but it's more safe, I would say. So in this architecture, from the bottom, you will have hardware, so 3 machines. Distributed storage manager, so it means that if you lose the data on one computer, or if you have a failure, it doesn't matter because everything is replicated on the second one. And you will also be able to detect whether system is done and everything will be transferred to another one. Okay. So now we've seen that we are able to build a high availability platform. However, it's a complex system, a very complex system. So how do you answer the reliability of such a system? There is one answer, is continuous integration. What is continuous integration? So basically, it means that you will test and document each evolution and correction, and you will do it automatically. And that's what we call the DTAP, so development, testing, acceptance, and production. And with that, you will be able, when there is an issue, to fail fast, and then to rapidly find a solution and to limit the cost. So what does it look like? So for the CPATH project, basically, when we build a Linux distribution, all the process is automated. So we'll start with the configuration file. So you have all the source code of the project. You will get it from your repository. And then you will do all the configuration regarding security, SSHK, this kind of thing automatically. Then you will build the image, and then the image will be flashed automatically on a hardware, and the hardware we start. And once the hardware is started, we'll run lots of tests to ensure that everything is correct. And then we will build the cluster. And once the cluster is built, we will run several tests. So just to give you an idea, today, when we make a modification and launch the test bench with the continuous integration process, we run around 1,500 tests each time, just to be sure that everything is fine. And every time we build a new functionality, we will add a test regarding this functionality in the chain. So every time we will run the chain again, then we will run a test regarding this functionality. So what is the continuous integration chain made of? So we will find all the what we call CPATH recipes. So basically, those are the configuration files linked to the Yocto project. Then we will find everything provided by the Yocto project to build the image. And then we use tools that are normally used in the IT world, but they are used a lot. Jenkins to automatic build the distribution, and Ansible to deploy the configuration on the hardware. And once it's done, of course, we have Cookinia. It's a tool that will allow us to play lots of tests on the system. And we're also working on a real-time test bench. So what we've done so far. So today, the continuous integration chain is fully functional, and we use it every day to build images. But we didn't focus on real time on this chain. However, we did some tests to ensure that it was feasible. And on the next part of the project, we will now focus on real time for production. So what do we know today? what we've done, we build a Yocto distribution, and we check with the preamp party patch what were the latency that can be achieved. And to use and to test it, we use cyclic test, which is a tool that allows to check the latency. So we see that on the host, so on the platform, we achieve a latency of 21 microseconds with the preamp RT patch. And for what we want to do with IC61850 and distance protection and differential protection, it's more than enough. But as we said before, the application will not run on the host, but on the virtual machine. So is it possible to achieve a good latency in a virtual machine as well? So we run the same test in the guests, and we achieve without any configuration and tuning. We just install the preamp RT patch and see what was going on, and we achieve a latency in 149 microseconds. That is good. Okay, so now you have a platform, you can host your application. You know that the real-time performance are feasible, even if it's need more tuning today, but it will be available soon. However, how do you ensure that your application with this type of hardware is working well? So that's the idea of the real-time testing CPath that is ongoing. So the idea is to build a test bench based on the DPDK, MoonGen, and the RFC 2544 to be able to monitor the performance of the application that are hosted in the platform. Here we are talking about network performance. Okay, so thank you for assisting this presentation. If you have any question, feel free to ask it. If you want to try to build your own CPath platform, you have the link right here. The project is on GitHub. You also have it on a wiki on the LF Energy pages. You have all the available documentation so far. And what we need, so today, of course, we need the end user feedback because the development is still ongoing. So if you have any question or remarks, feel free to contact us. And also, of course, if you want to participate, feel free to contact us as well. Anyone can join the meeting of the technical steering committee. It's public, and if you can also provide some code if you want, and if it's compliant with the guidelines, of course we will integrate it. Thank you for your attention. Have a nice day. Bye.
Hi, Aurelion. Welcome. Now you are live because it's a pre-recorded one. It's a question and answer session. Do I see any question in the box, in the question box? Please, for all participants, just throw in your question. Okay, I have the first question. Does CPath cater for mapping to IoT protocols such as SMPP, RESTful, MQTT for horizontal communication?
That's a good question. Actually, CPath focuses on the infrastructure. So if you put on it an application that can handle this type of protocol, the answer is yes. But natively, the CPAF infrastructure is not responsible of the protocol.
Okay, understand. Okay. Okay, question number 2. Okay, this is like okay, it's a CPAS project has been implemented in actual substation.
No, because it's a relatively new project.
Yeah.
However, at RTE, we use it as a base for the next control command generation. So it will be implemented. It will be qualified in 22 and implemented in a substation in 2023.
Okay, on that okay, this is my question now, because it's you're mentioning this CPAS project is going to provide a reference design, meaning that after the successful testing and implementation, we have to go to certain hardware manufacturers or system providers to actually give you this platform, coming up with this platform, because we are not doing any manufacturing and all that. How do you see that going after the completion of reference design?
The way we see it is we are not a vendor. We are not providing protection and so on. That is not our job. Our job is to ensure that we don't have to manage multiple platforms, because it's impossible for the maintenance. So once the platform is fully functional, we are actually also in discussion with vendors. And the idea is to say, okay, now we have this platform, it's working. We at RT, we will test it on several type of hardwares, like computer that are compliant with the IC 61-3 for the environment. And then we hope and we will imply to ensure that when a vendor want to sell us virtualized application, it will be qualified for this platform.
Okay.
I don't know if I answer your question.
Yeah, it is. Yeah, but my next question is, how is the in the earlier engagement with vendor, how was their response to this effort? Yeah,
that's a good question. So many vendors participate to the map of the project at the beginning. Okay, so the way I see it today is they do not want to accelerate virtualization, because of course for them it's and I can understand that it's a big change for the market. So the way I see it is it's like when it's the same thing as it was in the telecom. So they are monitoring the project. If the project takes 10 years, I don't think it will be an issue for them, because they will continue to sell boxes and their solution. However, if the project moves faster, they will join, because they do not want to miss the train.
Yeah.
So it really depends on us, I think.
Okay. You really depend on us utility, and then
Exactly.
we'll probably have to work with some probably a smaller vendors that actually can provide us with this, and then start to bring the big one in, because
Exactly.
they will probably miss the boat. Okay, that's so meaning to the question that a third party service, any collaboration with reputable IED OEM. I don't know what is your answer to that. Now, have we been talking to the big guns, the big three of the vendor?
Yeah, we're already talking with them actually. Some of them already participate to the technical steering committee. because the technical steering committee is public. So if you want to join, you're welcome. There is no, you don't have to register or to pay any fee.
Okay.
So to give you an idea, at the technical steering committee, we have discussion with Intel, with Schneider, with Advantech, with General Electrics. So yeah.
Okay. Okay. Oh, okay. That can you see the question and answer box on your screen, Aurélien? Do you?
Yes, right now, yes.
Okay. You see the first question. Can you just read it and answer, because I cannot read. I cannot even understand how to ask you
Okay,
that.
I understand.
Sorry.
Can you explain more on the third-party services application, namely
No, actually
protection
not
application?
that one. The
Oh,
top
no.
one. You see the did achieve a low latency.
Okay.
Yeah, those. Yeah.
You achieve the low latency using paravirtualization mapping to hardware directly. The answer is yes. But for me, there is two phases in the project. The first one is to show that real time is possible. We've done that. And the second one is customization to ensure that the protection application works perfectly well. So we did power virtualization. So we bind a CPU to one virtual machine, the same thing for memory. And we had good results.
Okay. Okay. So there's another one coming in. What will help to drive? Okay. I think we discussed just now, but we can continue the discussion. What will help to drive this software-defined virtualization towards an early adoption? Yeah.
Okay. For me, the first thing is to start with non-critical features, and then to put it in a substation, basically. So to handle automatons, and then you have to, then you will either work with manufacturer, or small, or like you said, to have the first protection working on it. And I think once this part is done, it's basically you have one. And at the same time, I think it's really important that the different utilities work together, like we do with Aliander, to show the vendor that this is the way we want to take. Because if it's just working alone, at some point it's not going to work. The vendors have to see that we are working together.
Okay, I agree very much with you on the facing in the function into the platform, because we are building platform that you can actually put function, whatever function you want and whatever function you like at any time you want, those kind of thing, and then start with the low criticality, like measurement or probably recording, all those kind of things first. That's not going to trip anything in the substation, right?
Exactly.
and then start from there, and then start to see the impact is coming. Yeah, and then move towards protection, maybe slower protection first, or maybe voltage regulation first in terms of control, and then move into the higher speed protection type. Okay. Next question is, do you split the software architecture into the run fast application on VM and near real time on container? Do you have that thing in CPaaS?
Speed sorry to run fast application. That's a good question, actually. Okay, so since we had a legacy, so the first answer, you can run everything on virtual machine if you want. You can run a protection on a virtual machine, and we have already done that with one vendor, and it's working on the laboratory, and we achieved exactly the same performance than with real protection. So, but you're right. I understand your question. It's container are faster, for sure. But the question is, do we need to go faster? Because today we have a legacy application that are now not working on Linux. So in any case, you have to use virtual machine. But of course, CPaaS is able to handle containers, and you could choose to run your real-time application on container. But it's working on virtual machine as well.
Okay. Okay. Any question from the floor, or maybe okay? One last question from me. In order to be involved, the source code and everything is available, right? For us to actually go and try this out, the CPaaS platform. Not us, sorry, for everybody, for an interested party, if they want to try this platform out in their lab or whatever, so we can actually get everything from the Linux Foundation website.
Yes, I will. I will just put the link in the conversation. However, let's be honest. The documentation we put on the LF Energy wiki page is a little bit complex because it's made to build a full cluster. Okay. So to have and so right now with my colleague we're working on a more easy one, I would say, to help people just to get involved and to just install it on the lab easily. I think in a couple of weeks you will have a easier version.
Yeah. Okay. So that, that's a good one. Yeah, that's a good move, because with that, then many more people can do the test, can do the trial on that, and then come back to you with feedbacks and suggestion and all that. Yeah. I think it'll good move. We'll probably, we'll probably use this or probably wait for that, because if we go to this and like you say, it's too complex to actually go forward. Might as well wait for a few weeks and then get. But it's going to be on the same link, I believe. Yeah. Okay. Great.
We'll just update the documentation.
Okay. Oh, okay. There's a late question coming in. What is the maximum latency on hypervisor feasible to run fast real-time application? Sorry, you can see the question, right?
Yeah. So in a virtual machine, it's a really complex question because it really depends on the input output. So because you can have your application that run fast on a VM. So if we talk just about the application without input output, today I think the minimum we achieve is 66 microsecond latency. But you have lots of configuration to make to not have issue with the network as well, because it's 6150, so you will receive data from the network. And right now we are working on this part too. So low latency network and low latency virtual machine, both are connected, of course.
Okay. All right. Okay, Aurélien, it's nice to have you today. It's great to actually have you today with your presentation and a very good Q&A session. So I'd like to thank you and then appreciate your presence in this workshop. Thank you very much.
Thank you very much. Bye-bye.
Bye-bye. So that would be the end of our second day, the utility sharing session, where we have actually listened to 6+1 paper, because Petronas has one extra paper in their presentation. So from the whole session this morning until now, it looks like utility has almost the same aspiration. Of course, for utility, all this work is actually to be ready for the energy transition, whatever coming in the future, for the sustainable future. So for the SDS, in terms of SDS, every utility that we here today is going towards the route of less complexity in the substation. And then, of course, the main point is there. The why is actually to reduce the total cost of ownership in terms of having a reduced hardware, and then, of course, with reduced hardware, there's reduced maintenance and all that. And also relating to energy transition, increasing the flexibility, functional flexibility is also another topic discussed today. Of course, with the flexibility on the power system, like we have a penetration of renewables and all this, it will change all the power flow. And then, of course, the new new demand, introduced by the upcoming electrification of transport in terms of EV and all that, will actually make the flow of electricity become not as we have seen before. So increased flexibility not only in terms of power system. Now we are talking about increased flexibility in terms of even the secondary system, the one that is actually the brain of the operation of the power grid, protection, automation, and control. And then I also capture the I would say that the support for the digital transformation overall, because of the need of getting more information or more data from the field, real-time data, time series data that is to be used in many other area, like in the advanced asset management, like what Petronas is saying about the formation of digital twins, and for their remote autonomous system. And one big message also that I have from actually from this evening, this afternoon session from Sander and Aurelion, and also some part of the morning presentation, that we want to be, I mean, as utility, we want to be vendor agnostic. We want to have that freedom to actually not being tied up to anyone. So this is, I think that what is the probably the objective of formation of LF Foundation, and also our work with TNB, collaboration with Intel, is going through the same path. This is that we are trying to be that vendor agnostic type of going to the future, of course. Yeah. And then and all these things happen, all this virtualization and all that is happening now, and it is time to happen now. Is one thing is not to forget and thanks the group that are being putting their effort in the standard, IEC 6550 standard, especially now with the birth of the maturity of process bus, and then the reliability of goose messages and all that. So all this become I would say that not not very far to reach. It's not very far to reach because of we are working on the common standard, at least on the communication standard. But now the work on CPaaS, just now we can see we are I mean open source. Also now we are defining reference design in order to I mean combining with this, and then with support from the hardware manufacturer. I would say that hardware hardware now become a commodity. That's why we're looking at everything run on a commodity hardware. So everything has meaning that things has, I would say, that line up. All the necessary prerequisite has lined up for us to achieve what we are dreaming about then coming up to this workshop and then start to talk to people, of course. And then from all the I would say speakers also concerned. There's also concern on acceptance of utility personnel on this, because there's a lot of, I would say, the myth that if you put everything in the basket and then if the basket fail, but anyway, Olian has shown that the reference design can cater for you can actually put multiple of that if we are and then we also heard from SCE, we are putting 3 servers instead of 2 because they want to have more reliability. So that is very possible with this flexible I would say system configuration. Okay, that's probably okay. One more point that I noticed here. Everybody is talking about asking about how vendor will respond to this. Of course, the vendor will actually, this is a big disruption, I would say, on this side. We have disruption on the renewables, we have disruption on the grid side, on the power system side, but this also become a disruption where all this technology has come together, and then of course there's disruption to many business or maybe vendor have to think about now changing the business model. Okay, and then the last one that you put is a collaboration between utilities. It's very important to have to collaborate to actually becoming a force, hand together and becoming a force to realize this. I think very I would say that beneficial way to go into the future. Okay, I don't think I have more that I can capture today, but okay, I have to like end of today's session with that summary of what the insight or takeaway that I have gathered from today sessions. Thank you. Over to you, Hasrul, for any announcement.
Yep. Thank you so much. Thank you so much, Cik Nick, for for chairing the session. It has been a very fruitful one and a very elaborative one. After we have a 6+1 presentation just now, and you have pretty much summarized it very nicely. I think we on this hand have, the audience have benefited so much from it. The closing of the session has very much helped all of us to understand more about this sharing session from the utility. So if you just allow me before we leave, I would like to share again this agenda on the screen. And maybe I would like to get some help from our technical team to zoom up the agenda a bit. If you can see, my short announcement will be regarding for tomorrow. So yeah, tomorrow will be the 3rd day of this workshop, where we are now going to have the industry sharing session. So today was the utility, tomorrow is the turn for industry. And it's going to be in the same method. It's going to be also chaired by a session chairman, and it will be divided into 2 sessions, part 1 and part 2, which is part 1 in the morning and part 2 in the evening after the lunch break. So the session tomorrow will start as early as participants are required to gather in this platform as early as 8. Because by 8:30, the facilitator will start to announce the agenda for the day. And also, if you try to notice on the screen, the facilitator will be by Ms. Faradiba. So I will be passing the baton to her, and probably we'll meet again with you all some other time. So before formally closing the session for today, we are a bit very early in the schedule. So it's a good thing to do also, because now we can continue to our normal work at the office. And yeah, final say, I would like to bid again, thank you all. Thank you for being able to stay put on your seats. And terima kasih, arigato, danke, bedankt, salamat, danibat, shukran, kapkun, and gracias. We'll meet again tomorrow morning. Adios. Thank you. Over to you. And